Hi, this is Maggie. In this video, we're going to create an array of user-defined objects and send messages to the objects. We're going to work with the Proverb class from the video on creating a simple Java class. I'll link that here and in the description if you haven't created a class in Java yet. You'll want to know how to do that first. So we have a class called Proverb and a client program that creates a Proverb object and sends it some messages. You can see that Proverb has 3 fields, all strings, full text, prompt text, and origin. And we pass values for those fields to the one constructor. We can then send the getPrompt and getProverb messages. Our client program creates a single proverb and sends the 2 messages printing the results. If we run it, you can see it's printed the prompt suitable for use in a game, and then the complete proverb, including origin. Let's create an array of proverb objects. I'll write a new client program called Proverb Array Client. So right-click on the SRC folder, and I'll create a new class called Proverb Array Client. And I'll check the public static void main string args box. When you declare an array variable, you write the type of data that is in the array, followed by open and close square brackets. So int brackets is the data type declaration for an array of integers. Double brackets is the data type declaration for an array of doubles. String brackets is the data type declaration for an array of strings, etc. In this array, we'll be storing proverb objects, so we'll write proverb. And then we follow that with the open and close square brackets. That means the data type is an array of proverb objects. Now we need to specify the variable name, and as it's an array, that will usually be a plural noun. So I'm going to call it proverbs. So that is the variable declaration. Right now, we have a variable declared, but it has no value. Let's write a line of code that tries to print the value at index 0, so you can see the error. System out println proverbs sub 0, and Eclipse gives me an error. The local variable proverbs may not have been initialized. If you execute it without creating it in an IDE, you'll get the same error. If you see this error, remember you need to instantiate or allocate memory for the array before you can work with it. You'll get a different sort of error if you forget to allocate memory for an array that's a field of a class, but you will still get an error. So I'll delete the printing line, and let's create an array that will hold 5 proverbs. We'll write proverbs equals new proverb 5. After this line of code executes, my array reference, proverbs, now references a location in memory. However, that location in memory is an array that holds 5 null references. Let's write one more line of code and then run this in the debugger so you can visualize each line's impact on the program state. Let's create a proverb object at index 0 of our array. We'll write, after we've allocated the array, proverb sub 0 equals new proverb. And I'm just going to borrow our arguments from before. So I'm going to pass in some literal strings to create this one proverb. If you cannot control yourself, you cannot command others. If you cannot control yourself, and Klingon for the 3 parameters to this constructor. Let's dissect that. Proverbs is our array variable, and that array holds values of type proverb, our class or user-defined type. Proverbs sub 0 then is the 0th location in our array. On the right of the assignment statement, we are creating a new proverb object. That will evaluate to the memory location where that object is stored, and so that will be stored back in proverbs 0. So proverbs sub 0 will now reference our new proverb object. Let's quickly watch this execute in the debugger. We want to pay attention to how each line of code transforms the program state. I'll put a breakpoint on our first executable line, proverbs equals new proverb 5, by right-clicking over in the line numbers and choosing toggle breakpoint. And then I'll click the bug icon. Alternatively, I could choose debug as Java application from the Run menu. Eclipse asks if I want to change the perspective to the debug perspective, and I do. So, with it stopped now, we can look in the Variables tab and see that Proverbs does not yet exist. We have declared the variable, but we have not allocated memory for it or instantiated it. We'll step over this line. After we allocate memory, we can see the variable in the Variables tab on the right. It has a little arrow, meaning we can click that and open it up to see more. If we click it, we see the 5 array locations and their indices, 0 through 4. And we can see that each one is a null reference. These can each reference a proverb object, but they don't yet because we haven't assigned any proverb references to them. Let's step again, this time over our line of code that creates a proverb object and assigns the reference to Proverbs sub-0. And now we can see that Proverbs sub-0 is no longer null. It references a specific proverb, and we can click on the arrow next to that and open it up, and we can see the 3 fields and their values. So when we create an array of objects, we must allocate memory for the array, and then we must allocate memory for each object that we assign to the array. Now it's possible, of course, that some other part of the program has already created some proverb objects and sent us the references to store in the array. But somewhere, somebody has used new proverb to create a new proverb before we have a proverb object in memory. Okay, let's make the program a little more interesting by reading the 5 proverbs from a file. I'm going to click the red square to stop execution, and then switch back to the Java perspective by clicking the icon in the upper right. You can also do this from the Window menu. I've got a file here with 5 proverbs in it. It is organized as full proverb text on one line, prompt text on the next line, and origin on the 3rd line. And then the next line is the beginning of a new proverb, full text, then prompt text, then origin, etc. In Eclipse, if we want to open the file by using just the file name, we should place the file in the project directory. If you accidentally put a file in the wrong place, you can right-click on the file and choose Refactor and then Move, and then select where you want the file to be. Let's write a method that takes a file path as a parameter, and we'll open the file and create proverb objects from the lines of text in the file, and we'll return an array of proverb objects. I'll write public static proverb brackets read proverbs string path. So proverb brackets, remember, means an array of proverb objects. That's what we're returning from this method. And we're passing in the path, which is a string. Now, I'm going to use a scanner to read from the file. So I'll import java.util.scanner at the top of this file. And I'm going to start by creating a file object to check for the file's existence. So I'll import java.io.file. And we're not catching exceptions yet, so we'll add a throws clause, throws file not found exception. Okay, so we'll create the return array, proverb brackets proverbs equals new proverb 5. And then we'll create the file object, file equals new file path. We can use this to check that the file exists, and then use it to initialize the scanner. So scanner input file, and then if file.exists, input file equals new scanner file. Now we can loop over the file and create our objects. So while input file dot has next, and then we will read 3 lines from the file to initialize our proverb. Let's declare some variables up above, string proverb, prompt, and origin. And then we can read the 3 lines from the file. When we open the file reference variable will point to the beginning of the first line. Each time we call the scanner's next line method, it will return the text from the file up to the next new line, and we'll advance the pointer beyond the new line so it points to the beginning of the next line. So proverb equals input file.nextLine, prompt equals input file.nextLine, origin equals input file.nextLine. Okay, and now we want to instantiate a proverb object and store it in the next location in the array. I'll need a counter or stepper variable for that. Let me declare above an integer variable called index and initialize it to 0. So then we can write proverbs sub index plus plus equals new proverb, proverb prompt origin. This will evaluate index, so 0 to start, and then increment it. So next time through the loop, it will be pointing to the next location in the array. And we create a new proverb object and pass in the 3 lines we just read from the file. To be safe, we should check in the while condition that we aren't going to write past the end of the array. So let's have the condition be while input file.hasNext and index is less than 5. We could make this more general by passing the expected array length into the method, or at least by making that a constant. But really, an array list is the better way to do this because we can grow or shrink an array list as needed. So I'm going to leave this as is for now. We'll rewrite it in a moment with an array list. Let's invoke this method now and then iterate through the proverbs array and print them out. So we'll have to throw the file not found exception from main as well, as it's going to get thrown to main if it's thrown when creating the scanner, since we're throwing it from read proverbs. So let's add that throws clause in the main method header. Okay, and we need to import the file not found exception. So import java.io.filenotfound exception. And of course we need to return proverbs from the end of our method. And then back in main, instead of creating a new array of proverbs in main, we'll just set proverbs equal to read proverbs with proverbs.text as an argument. And then we'll loop through and print the proverbs. We'll write for int I equals 0, I less than proverbs.length, I++, and within the loop body, system out print line, proverbs sub I dot get proverb. We'll just print the full proverb. Let's run that. And we see our 5 proverbs from the file. Now let's just change this to be an array list, which will allow us to read until the end of the file without worrying about how many proverbs are in there. So in main, we'll change our array declaration to be ArrayList angle bracket proverb angle bracket. And we'll have to import java.util.ArrayList. In the for loop, the ArrayList doesn't have a field called length, but it has a method called size. So we'll write I less than proverbs.size. And then to index into the elements, we'll write proverbs.getI. That will return a proverb object, so we can then send that the get proverb message. You might be more comfortable doing that in 2 steps. First, assigning to a proverb variable the result of proverbs.getI, and then sending the get proverb message to that variable. Up in read proverbs, the return type is ArrayList open angle bracket proverb close angle bracket, and that is the type of the return variable proverbs. We'll write ArrayList proverbs equals new ArrayList proverb, open close parentheses. We do not need our index variable at all, as we'll just append each new proverb to the end of the array list. So we can remove that everywhere we have it. And in the file reading loop, we'll write proverbs.add and then pass in new proverb, proverb prompt origin. Now this should work with a file of any size. Let's test it with our file of 5 proverbs. And it works the same. So that is creating an array and an array list of user-defined objects in Java. If you find the code difficult to understand, I recommend stepping through the code in the debugger and simultaneously drawing a picture of what's happening. For example, here is a hand-drawn sketch of the array version of the program as the array is being filled. The array is shown as a rectangle of pointers with indices drawn above. Each pointer points to a proverb object as the objects are created and the array is filled. The variable index holds an integer value, which is the index of the next location in the array to be assigned a value. You can show this integer value, but indices into arrays are often shown as pointing to a location in the array, as index is shown at the top of the drawing. Keeping track of the variables in this way can help you understand an array processing algorithm, particularly when objects are involved and the syntax and concepts are new. There are some practice exercises in the description of this video that will allow you to program parts of the solution. I recommend you practice with those exercises. Then rewrite this program yourself in Eclipse. Once you can do that, you're ready to move on.